The problem is, particulate matter pollution from agriculture like grain dust is affecting the air quality. This is a problem because grain dust contains bacteria, fungi, and other matters from harvesting grains, which contaminates the air we breathe. Exposure from particulate matter can cause illness and even birth defects. A study says corn production accounts for 4,300 premature deaths due to air pollution in the United States every year. Grain dust affect humans, especially farmers, animals, and plants.
These particulates are caused by the direct, primary input of particles through various methods in grain processing that leads to parts of the grain being released. Grain is a dusty and organic component that is thoroughly altered through processing, causing small particles of the material to be released from the grain and, if not properly caught, into the atmosphere. Components that cover the grain, such as fertilizer, pesticides, mold, mildew, dirt, and insects parts are also released into the atmosphere in this way. As the particles are primarily organic and relatively large, the pollution we studied is not very secondary. These particles are caused by the direct, primary input of particles through various methods in grain processing that leads to parts of the grain being released. Grain is a dusty and organic component that is thoroughly altered through processing, causing small particles of the material to be released from the grain and, if not properly caught, into the atmosphere. Components that cover the grain, such as fertilizer, pesticides, mold, mildew, dirt, and insect parts, will also be released into the atmosphere in this way. As the particles are primarily organic and relatively large, the pollution we studied is not very secondary. The largest cause of particulate matter release occurs through the loading and unloading of grains across the industry, which produces grain dust through movement. Dust is also given off during storage, chafing and cleaning of grains, sizing and inspection, and the repeated process where grain is grinded, crushed, mixed, and separated. The issue was recognized by many health regulations and laws. The Clean Air Act, enforced by the EPA, regulates particulate matter and enforces laws since 1963. Control of substances hazardous to health regulations also recognizes particulate release from grain processing, but was enacted in 2002 as amended. Various studies regarding the extent of the issue were also done later still, around the 2010s.
Our proposed solution is to add proper ventilation in silos where grains are being processed. It should work by filtering out the grain dust from the silos to reduce buildup and pollution within the silo. The advantages are reduced particulate matter and risk of respiratory problems in humans caused by excess grain dust. The main disadvantage is cost. It will be expensive to implement proper ventilation systems in a silo, especially on large-scale farming operations. We will test our solution by emptying 2 silos on a farm, cleaning them, and installing a ventilation system in one of the 2 silos. We will also install 2 dust wall collectors in each silo to measure the amount of grain dust. Then we will allow the silos to operate normally for approximately a month before collecting the dust wall collectors. We will then measure the amount of particulate matter collected in both silos and form a conclusion regarding our solution. The control will be the normal processing silo with no added ventilation. The independent variable is the added ventilation system, and the dependent variable is the amount of particulate matter or grain dust collected in each silo. Our hypothesis is that the building with proper ventilation will have less grain particulate matter than the normal building used during processing. For this experiment to be considered a success, we would have to conclude that the added ventilation system reduced the amount of grain dust pollution in the silo. This would be shown if the dust wall collector in this silo collected minimal particulate matter. The experiment would be considered a failure if the dust collectors in both silos collected similar amounts of grain dust. This would mean that the ventilation system made no difference and our solution is not viable. Solution will require a semi-large economic investment. Proper ventilation structures cost anywhere from $600 to $1,080. Companies must want to have ventilation systems installed and be willing to pay for systems for all of their silos. Furthermore, grain companies and farms who sell their product must follow government criteria, so we have to ensure our system does not violate government standards. If everything runs smoothly, installation of a single ventilation system should take about a week to empty the silo and install the fans and vents.